Hello, welcome to Online Physics. This is Unit 1, Lesson 1, Lesson 2 on graphing. So we're going to be using this worksheet that I made to look at how graphing works. And we're graphing something kind of unconventional. So the situation that we're graphing is the ticket prices as time gets nearer to a Justin Bieber concert. So we're constructing a ticket price versus time graph. So the first thing to mention is that when I give you a title, it is always going to be Y versus X. And that's usually the general way titles will get constructed. So that's the first thing that we can write down. Next, we already have our labels, so we can write those down as well. We have ticket price on this side. And we want to make sure we have our unit, which is going to be in dollars. And then here at the bottom, we'll have time, which is going to be in days. So those are our two units. Next, we want to figure out the scaling. What we do for the scaling is we take the biggest number and divide it by the number of boxes that we have. So in this one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 boxes that we want to graph. So we look at the X numbers and we see that 50 is the biggest box, or is the biggest number. So we're going to take 50, divide by 10, right, and that gets us 5. Right? And if we were to write units, it'd be 5 days is equal to 1 box. Right? So what that means is that if we go by 5 for every increment, we will reach 50 by the exact end. So we have our 0 here. I'm just going to do every other. And just do 10, 20, 30, 40, 50. There we go. Easy. For ticket price, we can't look at the bottom. We'll have to look at the top. So we have 35. We take $35 dollars divided by our 10 boxes. Right? That gets us $3.5 dollars per box. Now, if we increase by 3.5 for each increment, that would be, kind of a weird increments. You'd have 3.5, 7, 10.5. It's kind of weird. So what we can do instead is just round up to the nearest kind of nice or easy to add incremental number. And the next closest one I would say is about 5. So we're going to go by 5 as well. You can't round down because if you round down, you'll run out of space. But if you round up, you won't run out of space. So if we do that, we can do the same thing. We'll have 10 here, 20, 30, 40, and 50. So now we just want to start graphing our points. Our first point is 35, 0. So we have 35, 0. Then we have 30 and 10. So we have 30 here, 10 here. 27 and 20. So we have 20 right here, and then we go to 27. Something about right there. Then we have 19 and 30. So we go 30, and we go to 19. We have 17 and 40. So 17 maybe just about right there. And we have 16 and 15. All right, so those are our data points. Next, we're going to want to graph, or we want to draw our line of best fit. In our line of best fit, it's going to be something that kind of balances out the rest of the points. So if we pretend our points were little weights, we'd want to balance those weights out. We know that our starting point is, in fact, right here. So we want that to be in our line equation. So I'll draw a straight line here. I'm just going to drop this one anywhere because the formatting for these lines can be kind of weird sometimes. Drop that there. Kind of look at that. Looks like it's a little bit too high. I want to make it a little bit lower. Actually, maybe something like that. That's pretty good. So if you're to make a graph like this, where it has we have the labels, we have the units, the scaling, the data, and the line of best fit, that would be great. You would definitely get 100% for that graph. So now we want to answer specific questions about this graph and be able to read what it really means. So first is, what is the slope of your line? We know, hopefully you know, slope equation is m equals y2 minus y1 over x2 minus x1. Now we got to pick our 2 points. Usually, your data is not as nice as this. and not many points will lie in your line of best fit. Luckily for us, we do have two. We have this one right here and this one right here. But usually what happens is I see students who will plot and use data points that aren't on the graph. For example, if we were to use the third one, this one right here, and let's say maybe this one right here, right? That would give us a line that's kind of actually more like that. And that's not what our line of best fit represents. So we want to pick two data points that are actually on our line. And what that means too as well is we don't actually have to pick data points. We can really pick any line that is on or any data point that is on the line of best fit. So for example, let's use, we can use this one, so I'll circle it. Let's also use, let's see, just to be a little bit different, let's use right there. There's a pretty close intersection, so my point 1 is easy. It is 0, 35. And our second one is actually going to be 35 and 20. 35 and 20. It's our point 2. So we can kind of plug those in. It'll first be 20 minus 35. Zoom in on this a little bit. And that is over 35 minus 0. And that's an easy one to do. Right? When we take 20 minus 35, that doesn't just give us 15, it gives us negative 15. So that's important. 35 minus 0 gets us 35, and we're going to want to divide this. So 15 divided by 35 will get us negative 0.42. And that's our slope. Some things to point out. It's good that we got a negative because our trend is definitely negative. It goes down over time. And 0.42 sounds, pretty approximately right. It doesn't decrease too much over 50 days, so that sounds good. Units of your slope. This is pretty simple. All we're going to do is we're going to take the units for the y-axis, so the y unit over the x unit. Now when we do this, it literally means the unit. You can treat units like variables. So we just had up here with the slope, we had y's over x's. So we can do that with the units too. The y unit is dollars. The x unit is hours. So literally, our unit is, that's it, dollar per hour. Right? Because the slope tells us how much decrease we have in dollar amount per hour. Cool. So now, instead of going down, let's go across. I realize that this worksheet is numbered kind of incorrectly, but it's okay. What does a line of best fit describe in this case? So any line of best fit describes an average something. So the average, and specifically for us, when we look at our situation, it is, if we go back to here, ticket prices as time gets nearer to a Justin Bieber concert. We look at the trend and we see it's going down. So what this is the average decrease in price over time. Right? This question, in this particular case, should the line of best fit go through the origin? Why or why not? We're going to say no. Line of best fits don't ever have to go through the origin. That's just a special case. If you have, for example, maybe a marathon runner running a race, it makes sense that their line of best fit would go through the origin because that would be representative of the starting point. Right? You start a race at 0 meters. You don't start ahead of the other runners. In this case, when you're selling tickets, you usually start them, at more expensive prices. As time goes on, you want to sell them for a little bit cheaper sometimes, if they're not selling well. And we know with Justin Bieber, it's not going to sell too well. So no, ticket prices shouldn't be $0. If they were free, they wouldn't make any money. So they're starting at 35. Cool. Easy. Using the line equation, we're going to go to this one right here. Y equals mx plus b. Construct your equation for your line. So we start there. Y equals mx plus b. We throw in our slope. So y equals negative 0.42. X And then B is just our intercept, our y-intercept, and we know that that is $35. So that's it right there. Lastly, what will the ticket price be after 90 days? Will this be a good time to buy a ticket? Hint, it's never good to buy a Bieber ticket. Sorry if you like Justin Bieber, it's just easy to poke fun at him. So let's plug that in, 90 days. That is our that is our x-axis variable, so we're gonna plug it into our x variable. So we have 0, negative 0.42, plugging in 90 plus 35. So when we do that math, negative 0.42 times 90, that equals a negative 37.8 plus our 35, right? We get a price of negative 2.8, right? And this is $2.8. So what does that mean? That means you would have to get paid to go to a Justin Bieber concert, and that's how it should be. No one should ever have to go to a Justin Bieber concert of their own will. So this is actually, honestly, kind of a nonsense answer. It's kind of just comical to myself. But this is what it's saying. It's saying that if this was a positive 2.8, it would cost $2.8 to buy this concert ticket. But if it's a negative, they're actually just trying to get people to go and show up to this concert, to make it look like it's packed. Or at least that could be an explanation for that. So that's how I want you to be graphing. That's how I want you to read graphs in this class. So being able to construct this is very important. So I'll scroll down really quickly, slowly, so you can stop at a certain point and pause the video if you want to. But other than that, being able to do this should get you to the right place. So that is all.